Hello everyone and welcome back to MathZone. In this video we are going to learn about trigonometry and already learn and use some of the formula to solve circular measure problems. Now let's look at how do we calculate three basic ratio of trigonometry, which is sine, cosine and tangent. So we already used this formula in the previous chapter, but we are going to use it again, so let's recall first. For the basic formula, we have SO stands for opposite over hypotenuse for sine, K means cosine equals to adjacent over hypotenuse, and TOA stands for tangent equals to opposite divided by adjacent. Now, let's look at the right angle triangle. Because SOHCAH TOA only works for right angle triangle, so let's look at this triangle. We put our theta here, that means this is our opposite side, this is our adjacent side, and this is the hypotenuse. So by using SOH, we can write down the formula of sine. So sine theta equals to opposite divided by hypotenuse. You can use K to write down the formula of cos theta. Cos theta equals to adjacent over hypotenuse. And the last one is TOA for tangent. So tangent theta equals to opposite divided by adjacent. Now, you can calculate the value of sine, cosine, and tangent for any angle you have, as long as you have the triangle and you have the opposite, adjacent, and hypotenuse. But we can calculate the value of sine, cosine, and tangent without writing or drawing right angle triangle if the angle is a special angle. So in trigonometry, we know that we have 5 special angles, which is 0, 30, 45, 60, and 90. And this will be useful if you memorize the value of trigonometry special angles. So without even drawing the right angle triangle, you can find the value of sine 30, because 30 is special angle. You can also calculate the value of cos 60 without drawing the triangle by memorizing the table. Now, what are the values? For sine 0, the value is 0, and then 30 is half, and then 45 is half square root of 2, half square root of 3, and 1. Cosine will go opposite, 1, 1 over 2 square root of 3, 1 over 2 square root of 2, 1 over 2, and 0. So how do we memorize it easily? Here's I have the way. So you put square root over 2 to all cells we have here in the table. Square root over 2, 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 square root over 2. And then you just put the value 0, 1, 2, 3, 4. For cosine, start from 4, 3, 2, 1, 0. Now if you calculate the value, that will be equals to the previous value that I have written. So this is the way how you memorize the value of sine and cosine. What if you want to calculate the trigonometry angle but not special angles? For example, sine 15 or cosine 41. For this one, I suggest you to use calculator. Well, we can use calculator as well to find sine 30 and cos 60, but it will be useful in the future later if you memorize it. So this is how you calculate the trigonometry special angles. but unfortunately the special angles only up to 90 degree. So how do we calculate trigonometry value that is bigger than 90 degrees? Or maybe how do we find the trigonometry value that is negative angle, for example sine minus 15? To find that, we need to understand about basic or reference angle, guys. In the basic or reference angle, we can use this concept to find the value of trigonometry function for all angles. But first thing first, you have to understand how to draw general angle. So to draw general angle, first thing first, you have to draw first 4 quadrant. So the top right, we call it as the first quadrant. The top left, second quadrant. Left bottom is third quadrant, and the last one is the fourth quadrant. Okay, how do we draw an angle? This is how we draw the angle. If you want to draw the angle, always start from positive x-axis, which is this one. Always start from here. And then if you want to draw positive angle, you have to go anti-clockwise. So let's say I want to draw 30 degree. So approximately 30 degree, if we sketch, we can use a line. Start from origin and you take a straight line, and approximately the angle between the line and the positive x-axis is 30 degree. You go anti-clockwise. Let's say I want to draw 120 degree. So approximately here, you go anti-clockwise. This is 120 degree. You go clockwise because the angle is positive. What if I want to draw 270? It's positive, so you go clockwise. It will be this one. From here to here, it's 270 degree. Now, what if you want to draw negative angle instead? If you want to draw, for example, negative 60 degree. So instead of going anti-clockwise from positive x-axis, you go down, you go clockwise. So you draw approximately 60, and this will be 60 degree, negative 60 degree, because negative go clockwise. And then if you want to draw, for example, minus 180, so it goes 180 degree around here. This is minus 180 degree, and this will be your line. So this is how you draw general angle. What if I want to draw an angle that is more than 360 degree? So if you want to draw an angle more than 360 degree, let's say I want to draw 370 degree. So first thing first, you have to go one full rotation first, because we know that one full rotation, wait, let me use different color. One full rotation is, oh, the color is too bright. Wait. So we go one rotation first. This is 360 degree. Now if you want to draw 370 degree, you have to go 10 degree more. So let me draw it from here. It's approximately here. So you go by additional 10 degrees. So this will be 370 degree, which is in this case equals to 10 degree, because it goes one full rotation and then you go additional 10 degree. So you will have 370 degree. Right? That also works for negative angle that is less than negative 360 degree. Okay, if you know how to draw the general angle, we can find something called basic angle or reference angle. This is very useful because if you know the value of basic angle or reference angle, you can calculate the trigonometry value. So let's see the definition of basic angle or reference angle. Basic angle or reference angle is the acute angle made by the line and the x-axis. So let's look at some example. Let's say I want to draw 135 degrees around here. So I have theta equals to 135 degree. What is the basic angle of our theta? The basic angle is the acute angle made by the line, which is this one, and the x-axis, not just positive. So can be negative, can be positive, this one. So the acute angle is this one, which is 45 degree. How do you get that? You just subtract 180 degree minus 135 degree, you get 45 degree. So the basic angle is 45 degree. Let's say I want to draw, for example, let's say I want to draw, for example, 270 degree. So it goes this way. This is our line. So what is the basic angle? Basic angle created by the line and the x-axis. So the acute angle created by that is this one, which is 90 degree. So you can say that if the angle is 270 degree, the basic angle is 90 degree. What if the angle is 180 degree? What is the basic angle for that? If you draw 180 degree, so it goes this way. So this is the line. Let me use different color. This is the line. So the line and the x-axis creates 0 degree because it's parallel. So you can say that if the theta is 180 degree, the basic angle is 0 degree. So this is how you calculate the basic angle. It's always the acute angle made by the line and the x-axis. And keep in mind that the value of basic angle is always positive, cannot be negative. So we always take the positive value. Okay, if you know the basic angle for each theta that we have, now we can calculate the trigonometry value of any angle that you want. This is the formula. Sine theta, cos theta, and tangent theta equals to plus minus sine of basic angle. Cosine theta equals to plus minus cos of basic angle, and that also same for tangent. So I can say that the sine of any angle will be equals to the sine of corresponding basic angle. But you have to put plus or minus sine. And that's same for cosine and tangent. But how do we know which one do we choose? Plus or minus? So this is the convention that you're going to use. You can say all smart trick class A, S, T, C. So you can draw first the fourth quadrant. Yeah. The first quadrant is for A, which is all. All means that the angle in this quadrant is always positive. The second quadrant is sine, which is S, smart, the second quadrant. That means only sine value that is positive. Cos and tangent is negative. The third quadrant we have tangent that is positive. That means sine and cos negative. And the fourth quadrant cosine is positive, means that sine and tangent negative. So let's look at some example. Before I already draw this one. Let me copy paste. I have 135 degree. Okay. So first thing first, let's say I have the equation sine 135 degree, cos 135 degree, and tangent 135 degree. Okay, first thing first, how do you find the value of sine 135 degree? You have to find the basic angle. Your theta here is 135 degree. So already find that the basic angle is 45 degree. So the sine of your angle will be equals to sine of your basic angle, which is 45 degree. And that also same for cosine. But you have to put plus minus depends on the quadrant. Because your line here lies on the second quadrant, that means only sine that is positive. So you put plus here, but cosine negative, because on the second quadrant only sine that is positive. So as you can see, we can use the table. Sine 45 is 1 over 2 square root of 2, minus cos 45 is minus 1 over 2 square root of 2, because sine 45 and cos 45 from the table are equal. And to find tangent 135, you just divide the sine value of 135 with cosine value of 135. So you divide 1 over 2 square root of 2 divided by negative 1 over 2 square root of 2, which is equals to negative 1. And as you can see, by using the formula of tangent theta equals sine over cos, you can see that it's negative because second quadrant tangent is negative, only sine positive. Let's say I want to find the value of cosine, let's see, 210. First thing first, you have to find the basic angle. So you draw it first, 210 approximately here. This is 210. So the basic angle is this one, which is 210 minus 180 degree. You will get 30 degree. So cosine 210 equals to cosine of its basic angle. But you have to check, guys, because we have the third quadrant here, only tangent positive, our cosine will be negative, so it becomes minus cosine 30 equals to minus cosine 30 is, look at the table, 1 over 2 square root of 3. So you will have minus 1 over 2 square root of 3. You can apply this to find the negative value. For example, sine minus 60 degree. If you draw the angle, it's around here because we go clockwise for negative angle. So this is negative 60 degree. And the basic angle for that will be 60 degree as well, but no negative, because basic angle is the angle created by the line and the x-axis, but basic angle always positive, so we only take the 60 degree. So sine negative 60 degree equals to sine 60 degree. But because the fourth quadrant, we have the fourth quadrant here, only cosine positive, so we have to put negative here. So that equals to negative 1 over 2 square root of 3. You can also use this concept to find the angle for more than 360 degree. So let me erase this. Let's say I want to find sine, let's see, 390 degree. So how do you find sine 390 degree? So you draw the angle first. 390 degree is 360 degree. Sorry, 360 degree. Yeah, and then you go 30 degree extra. So around here, this is 390 degree. The basic angle is 30 degree because basic angle created by the line and the x-axis. And because this is the first quadrant, all positive, so we have positive sine basic angle. So you will get 1 over 2. So you can find the value of trigonometry for any angle that you want. Move on to the next part is the trigonometry function. If you already know how to calculate all of the value of trigonometry, any angle, now let's plot it into our graph. Trigonometry function, we have 3, the sine, cosine, and tangent. Trigonometry function, the first function is y equals to sine x. The shape of the y equals to sine x graph is a wave. It's like a wave. And as you can see, the wave consists of one hill and one valley. This is, we call it as one wave. And then this form will repeat. Will repeat continuously, and that also go backwards. So as you can see, we have lots of hill and valley. Now, let's see what can we have from this graph. First thing first, we have the middle line that separates the hill and the valley. We call it as principal axis. Principal axis is the line that separates the hill and the valley. The second one is amplitude. The amplitude is the height of the hill or the depth of the valley. It's the same. So we can see that the distance from the principal axis, the middle line, until the peak is 1. So we can say that the amplitude is 1. And then before we have principal axis, the principal axis is the middle line that separate the graph into two. We have y equals to 0 because it lies on the x-axis. Now, let's see the third one. We have something called period. The period is horizontal distance for one wave. Once again, one wave consists of one hill and one valley. So from 0 to 2 pi for sine x. So that means the period for sine x is 2 pi. The amplitude is 1, period is 2 pi, principal axis is y equals to 0. Okay, now let's see the general form. This is only for y equals to sine x. But what if we do some transformations of function? We already learned that before in function chapter, so we can apply it to our trigonometry function. This is our general form. Y equals to a sine b in the bracket x minus c plus d. The first one, we multiply the sine, means that will affect our amplitude. So you can make the amplitude bigger by multiplying your sine with a value or make it smaller. The second one is b. B is the one that control your period, because this is like the horizontal stretch. And to find the period, you just need to divide 2 pi over b. This is the formula of the period. The second one is the horizontal shift, because we already learned about horizontal translation. When we subtract the value of x, that will give you horizontal translation or horizontal shift. And then for d is the principal axis, means that you can move the graph up and down. That will change the principal axis location. That is the first graph. Now guys, let's look at the second graph, which is y equals to cos x. For y equals to cos x, the graph is similar to sin x, but you have to pay attention that the starting point different. For sin x, it starts from 0, 0. But for cos x, as you can see, it starts from 0, 1. It starts from the peak. So that means for y equals to cos x, it starts from 0, 1, or the peak. Now, the cos x also have principal axis, which is the middle line of the graph. We call it principal axis. It also have amplitude, which is the same thing as the sine, and the period also basically same thing, 2 pi, because inside of this range we have one valley and half the hill, another half hill. This plus this becomes one hill, one valley. It's the same thing. So for the cos, we have exactly the same thing for the amplitude, period, and principal axis. The one that makes it different from sine is starting point. For sine, the starting point is 0, 0. For cos x, it's from 0, 1. Now, let's look at the general form. Is 100% same thing as sine. A for the amplitude, B for the period, 2 pi over B, C for the horizontal shift, and D is the vertical shift or principal axis. It's the same thing as sine. It just have different starting point. The last one and a little bit different is tangent. In the tangent, the graph shape will be different. If you see, for one wave of tangent, it's not one hill, one hump, but one of this thingy. This is one wave, or we say one period for tangent, from here to here, from minus pi over 2 until pi over 2. So that means the period will be pi over 2 minus pi over 2. You will get pi. So the period of the tangent x, this is y equals to tangent x. The period is pi. For sine and cos is 2 pi. Unfortunately, tangent x does not have amplitude. The amplitude is none. As you can see, the graph does not have a peak, does not have the most bottom, the lowest value. So no amplitude for tangent x. And the principal axis for y equals to tangent x, the same thing. It's just the line that divides the graph into two. This one, this curve, and this curve. So the principal axis, same thing. It's y equals to 0 for this case. Now, as you can see in the y equals to tangent x, the graph will repeat the shape because it's a periodic function similar to sine and cosine. But if you pay attention here, we have dash line, vertical dash line that indicates the asymptote. So all of the dash line, we call it as the asymptote. What is the asymptote? The asymptote is a line where the graph will never touch this asymptote. So if you see the graph here, that will go up forever, infinitely. This goes up forever, but I can guarantee you this graph will never touch this asymptote. And that's same for the other side. This graph will go down forever, but will never touch this asymptote. Why is that? Because if you see the asymptote, it's, let's say I take one asymptote, it's pi over 2. What happened with pi over 2? So if we substitute the value of pi over 2 to our function y equals to tangent pi over 2, or maybe you're more familiar with the degree, which is 90 degree, it equals to sine 90 degree over cos 90 degree. And we know that sine 90 degree is 1 and cos 90 degree is 0. And if you use calculator, it's undefined. Means that it's illegal. You cannot have a number divided by 0. It's undefined. Means that the tangent function does not have a value at the asymptote. And that will repeat every pi because that's the period. Now, for the general form of tangent, A does not mean amplitude. Be careful, tangent does not have amplitude. A here just change the shape of the curvature, but not amplitude. The B, same thing. The period, we can find it by dividing the pi, not 2 pi, because tangent period is pi, divided by B. C and D, same thing. Horizontal shift and principal axis. So in the past paper, you are going to draw trigonometry function, also the general form, so you can see the next video for that later. Let's move on to the next one. We have inverse trigonometry function, guys. What does it mean by inverse trigonometry? So let's say I have sine 30 degree and then we want to find the value. Well, we know that from the table the value is 1 over 2. But what if I change the equation? Sine x equals to half, and then we want to find the angle instead. How do we find that? Well, you can check on the table sine of what value equals to half, or if you forgot or the value is not on the table, you can use something called inverse trigonometry function. It's the inverse function of sine x and also cos and tangent later. And you can write down like this: x equals to sine inverse 1 over 2. And then use calculator to get 30 degree, which is the value. Now, let's see the function of inverse trigonometry. We have 3. The first one is sine inverse x. So this is our y equals to sine x. Now, recall that inverse function exists if the original function is 1 function. But we know that if we go back to our y equals to sine x, it's not 1 because if you take a horizontal line, it has a lot of intersection, means that it's not 1. So to make it 1, you have to limit the domain so that when you take a straight line, horizontal straight line, it only has 1 intersection. As you can see, this is our limited sine x. You limit the domain, becomes x is in between minus pi over 2 until pi over 2. So by having this, we can draw y equals to sine inverse x, and this is the shape. As you can see, the coordinate here is pi over 2 comma 1. We swap, becomes 1 comma pi over 2. And then this one minus 1, and this is minus pi over 2. You swap, and then the shape will be like a reflection on y equals to x. So you can draw y equals to x, and then this is the reflection. And you can apply the domain and range concept for inverse trigonometry function. Because we limit the domain for y equals to sine x, the domain will be x is in between minus pi over 2 until pi over 2. The range will be from minus 1 to 1, because for sine x, as you can see, the maximum is 1, the minimum is minus 1. For the sin inverse x, we know that the inverse, the domain will become the range. So the range will be from minus pi over 2 until pi over 2. And the range of fx will become the domain of f inverse, which is x is in between minus 1 until 1. You can see it from the graph as well. The second one, we have cosine inverse. For cos inverse, to exist, you have to limit the domain of cos x. So we can take this part of the graph, same thing, yeah. We can take it from 0 until pi to make it 1, 1. So the graph of cos inverse x will be like this. So from 0, 1 becomes 1, 0. 0, pi over 2, pi over 2, 0 becomes 0, pi over 2. Minus 1, pi becomes pi, 1. It's just the reverse. And the shape will be like this. You make reflection in the line y equals to x, and then you can write down the domain and range, same thing as before. For domain, for y equals to cos x, we limit the domain so that the function is 1, 1. X is in between 0 until pi. The range will be from minus 1 until 1. For cos inverse x, the domain of cos x will become the range of cos inverse, which is from 0 to pi, the y value. The range will become the domain, which is x is in between minus 1 until 1. And the last function is y equals to tangent inverse x. So we can take one wave of the tangent x, because if we take only one wave, it will become 1, 1 function. And then this is the asymptote, this is the undefined one. So we can limit the domain becomes y equals to tangent x. The domain here is not equal sign, but we take x is in between minus pi over 2 until pi over 2. But we don't take equal sign because at this point the graph is undefined. So this is the graph of y equals to tangent inverse x. As you can see, now the asymptote, the vertical asymptote becomes horizontal asymptote. We swap from minus pi over 2 until pi over 2, and then the graph goes minus infinity until infinity. So we can say the domain of tangent inverse x is the range of tangent x, because tangent x range is goes up forever, goes down forever, so it's all real numbers. So the domain of tangent inverse x is all real numbers. The range of tangent inverse will be the domain of tangent x, which is in between minus pi over 2 until pi over 2. So this is the inverse trigonometry function, guys. Now, the last one, we are going to learn about trigonometry identities. There are two main formula. The first one is the one that I already used. Tangent theta equals to sine theta over cos theta. And the second one, sine inverse theta plus cos inverse theta equals to 1. How do we know it's true? So for the first one, we know that sine theta over cos theta, for sine is so. So opposite, let me use thinner one, opposite divided by hypotenuse. And for cosine, we have adjacent over hypotenuse. So we can cancel the hypotenuse. We will get opposite divided by adjacent, which is equals to tangent theta. So kah toa. The second one, we can also prove this formula. Sine squared theta is just mean you have sine theta being squared. The same thing. Plus, we have cos theta being squared. So why is it equals to 1? Let's see. Sine theta is opposite divided by hypotenuse square, plus cosine is adjacent over hypotenuse square, and then we have opposite square plus adjacent square over hypotenuse square. Because in the right angle triangle, we can apply Pythagoras. This is opposite, this is adjacent, this is hypotenuse. By using Pythagoras, opposite square plus adjacent square is hypotenuse square over hypotenuse square. So this is the Pythagoras. So you will get it equals to 1. So we are going to use this formula later in the past paper, so don't forget to watch the second episode of trigonometry. So thank you guys, and see you in the next video.